good morning, afternoon, evening, or even night for everyone who is watching. We are from Group 8, and right now we are going to talk about our computational thinking study case 2 for our final exam, and it is about structural health monitoring for bridges. And here are our group members. Myself, I am Afe Claudia, Juliana, Elisabeth, Mongan, used to be called as Afe. And here are my friends. The first one is Ananda Nelsafya, also called as Nelsa, Nasyandira or Nasya, and the last one, Nadia Larasati or Nadia.
This is our study case. For the background, bridges are critical infrastructure components that require constant monitoring to ensure safety and longevity. Over time, factors like heavy traffic, weather conditions, and material degradation can compromise their structural integrity. Traditional inspection methods are time-consuming, costly, and often reactive rather than proactive. So for the problem statement is, design a computational solution to monitor and optimize the structural health of a bridge. The solution should consider real-time sensor data, early detection of potential structural issues, prioritization of maintenance tasks based on severity, cost-effectiveness, and scalability for large-scale deployment. Your goal is to create a system that dynamically monitors and analyzes the structural health of a bridge using real-time sensor data, while balancing accuracy, cost, and maintenance efficiency. Additionally, your solution must incorporate at least one classic algorithm we have learned, such as linear search, finding extreme values, greedy algorithm, or brute force.
So here we already created a flowchart before to give us a better idea of how our program will work. Then this is our pseudocode. Here we define safety limits for vibration and load, and there are two levels, maximum and critical. Then we set the MV or maximum vibration for 2 millimeters, ML or maximum load for 30 tons, CV or critical vibration for 4 millimeters, and lastly, critical load or CL for 35 tons. And then for the functions, they simulate sensor readings from the bridge. Then each function handles part of the response system, like alerts, database logging, maintenance, or emergency inspection. And then for the time function itself, it returns the current time in hours to help us perform periodic checks for every 24 hours. Then for the main monitoring, as long as the monitoring is active, the system will run in a loop. And each cycle will read sensor data and finds the highest vibration and load values among all sensors. If the vibration or load exceeds the safe maximum, the system will sense alerts and logs the event. But if the values go beyond critical limits, it immediately requests an inspection. Otherwise, it schedules routine maintenance. Then for every 24 hours, the system performs a brute force safety check, where it logs risk analysis if any sensor exceeds safe limits, even if no alert is triggered.
We present a simple Python program designed for structural health monitoring for bridges. The goal of this program is to input and monitor for key parameters, that is maximum vibration, maximum load, critical vibration, critical load. We initialize default values for testing purposes. For MV is 2, for ML is 30, for CV is 4, for CL is 35. This number is based on our data representation and pattern recognition from our previous study case. This means that vibration above 4 millimeters indicates critical failure, where there's a high risk of cracks or structural collapse. Load is exceeding at 35 tons surpasses the bridge's design capacity. Meanwhile, anything over 2 millimeter vibration or 30 tons of load enters the warning zone, meaning the structure might be weakening or overloaded. So in this program, the values input by the user will later be compared to these thresholds to decide whether the bridge is in safe, warning, or critical state. And to stimulate what would happen if real-time sensor data is fed into the system, by collecting inputs through this program, we're building the foundation for a threshold-based alert system that engineers can use for decision making, from routine checks to emergency interventions. Each number that input is will convert it into a float so we can work with decimal values if needed.
On this slide, we can see the first part of our Python program designed for structural health monitoring. This code simulates sensor reading from 3 different sensors that measure both vibration and load. The read sensor function returns the data from each sensor. Then we have functions to log any anomalies detected, trigger alerts, log data into a database, request inspections, or schedule maintenance. For example, if a sensor values are abnormal, the system will detect it and print a warning like anomaly detected. It can then notify the engineers or ask for immediate inspection. This setup helps to ensure we catch any usual behavior in the structure early. In the second part of the program, we run the actual monitoring process using a while loop. It starts by calling the read sensor function to get the data. It prints a table of all the sensor readings, then it checks if the highest vibration or load exceeds a set threshold. If it does, it alerts the engineers and logs the anomaly. Finally, it checks whether the abnormal values are critical. If they are, it requests an immediate inspection. If it's not, it schedules routine maintenance. This helps automate the monitoring process and reduce manual checking, making our Brights monitoring system smarter and more responsive.
After that, for the last part for our Python code is that we do a brute force check. Here we use an if, and then we use for the sensor in sensor data for the final part of the code. And then below here we have an example of the results with numbers that we include by ourselves. For example, here we have maximum vibration in 1.7 millimeters, and then we have our maximum load in 33 tons, and then our critical vibration in 4.5 millimeters, and our critical load in 47 tons. And below it, we have the results that came out based on the codes that has been made before, and along with the numbers that has been input before. That is all for now, our presentation about study case 2 about structural health monitoring for bridges. Thank you for your attention and listening to our presentation. And here we have our link to our Google Colab codes that you can access. See you next time!